China remains the epicenter of the disease, with nearly 80,000 cases reported.
1,700 medical workers infected. Half of the country's population now under some form of lockdown.
In Italy, Pope, blessing and abandon St. Peter's Square.
Spain, the new epicenter of the pandemic.
Europe is now the epicenter of the coronavirus pandemic.
One day it's like a miracle.
No, I'm not concerned at all. It will go away. Just stay calm. We're in great shape.
No, I don't take responsibility at all. It's all over the world. This is a pandemic.
We are seeing the epicenter of the coronavirus outbreak shift to the United States.
With a record number of Americans out of work, thousands of people are lining up outside distribution centers all across this country just to feed their families.
महाभारत का युद्ध 18 दिन में जीता गया। कोरोना के खिलाफ जो युद्ध पूरा देश लड़ रहा है, उसमें 21 दिन लगने वाले हैं।
Migration on a scale that's never been seen before since India's partition in 1947.
A lockdown without any planning for India's millions of migrant workers and daily wage earners has led to a humanitarian emergency.
In Brazil, the health service is ill-prepared. In truth, it's already overwhelmed. They can't fight this virus. They're digging thousands upon thousands of graves. Brazil's President Jair Bolsonaro is still dismissing this pandemic as a light flu, but it's irrelevant what he thinks anyway. They're dying here in huge numbers, and it's nowhere near the peak.
We have two panelists, Dr. Yogesh Jain and we have Dr. Satyajit Rath, both of them very eminent in their fields. Yogesh did his medicine from All India Institute of Medical Sciences, and then he's been working in an economically backward region in a district, a rural health setting, working on public health, and also the founder of the Swasthya Sahyog, a hospital dedicated for caring for the poor and the excluded or the disadvantaged. Satyajit is an immunologist. He's done his medicine and then he's also done his PhD, and he's been researching this issue. And as you know, COVID-19, of course, one of the major issues is the immune systems and the problems the immune system has to tackle it, and of course the issue of vaccines. I'm going to start this discussion with handing it to Yogesh first to talk about, give us a brief overview of the issues that are facing us and where do you go from here. Yogesh, yours.
Thanks, Prabir. From the vantage point that I am in rural central India, I would like to unpack the science of COVID-19 as we see before we start discussing about its consequences on the society. So this global disease now, which has caused sickness in almost all the countries of the world, maybe except now North Korea, which hasn't reported as yet, is called a pandemic because it involves people in all the continents where people live. And it's called COVID because it is coronavirus disease, the first few letters of both the words. And obviously this is a new disease, not a disease older than 7 months now, caused by a virus called SARS-CoV-2, named because of the second, it behaves somewhat similar to the coronavirus that we had in 2002. And it was first observed in the last days of 2019, therefore it is called COVID-19, even though the major consequences it is doing is in 2020 and maybe 2021. It has caused havoc in terms of human lives, illness and deaths that we saw in the video also, but truly also in the economy, in the social structures and other human processes. And not for nothing, the UN Secretary General said that it has brought out the worst in us in human beings besides being a health crisis in form of our depravity, in our inequality and injustice to some people of the world. And not for anything, someone said it in the past, that it is in the crisis that our true selves show out. And it is also showing out some of our bad sides. If you look at the numbers that we see about the problem, the burden of the problem, over 16 million in a planet of 7,000 million, that's about 0.2% of people who are already diagnosed as diseased in the first 7 months of the pandemic, with about 650,000 deaths. There are good reasons to believe that this number of people infected is at least 5 times higher. So about 1% of the entire world human population is at the moment diagnosed, probably has had COVID. Compare this to the last similar sized pandemic that happened in 102 years ago in 1918, when arguably 1 in 3 people on earth, that is about 33% people, were infected. That is about 500 million people were infected then, killing about 50 to 100 million. Death rate of almost 10%, or about 2.5% of the global population in that period. This is not the first pandemic. So we have known pandemics to arise for several centuries. The commonest ones are those that spread due to respiratory secretion or are airborne, like the influenza group viruses which cause pandemics. Coronavirus group, this one is, we've had 2 coronavirus pandemics in the past, in 2003, which was called SARS, and in 2009, when we had Middle Eastern respiratory syndrome called MERS, which also caused much damage to people. And in the past, we've also had pandemics due to plague before economic and antibiotic development had happened. The last one was in 1890. Of course, we have also had pandemics of smallpox, cholera, and now the HIV disease in the last decades of the 20th century. Most pandemics, whether it's HIV or whether it's the pandemic of the influenza, they originate in animals. They're caused by viruses, and they're driven to emerge by ecological changes or behavioral human changes or socioeconomic changes that sort of speed up the occurrence of pandemics. But there are some, let's look at what are the special things about this particular coronavirus and the disease COVID-19 that it causes, so that explains its remarkable success in reaching all the continents. There are 3 major reasons. One is that it has a devastating combination of just being a bit more deadly than influenza. It kills about 1% of people who at the moment seem to have acquired the disease, compared to 0.1% kill that would happen in an influenza non-pandemic time. But it is far more transmissible, at least 3 times more transmissible than a flu virus. So compare it to a very infectious illness like measles, where it could be 15 people who will be infected per case. In COVID-19, it is about 3 people who get infected per person. And unlike flu, it has survived the first summer very well. And I don't know how many more summers are going to be there. But perhaps the most important reason why this virus can survive and transmit so wonderfully is that it has a large majority of infections are asymptomatic. Some argue that it's over 80%. And these asymptomatic people can infect others, unlike in flu, unlike in SARS that happened. And since it is an uphill task identifying asymptomatic but who are infected people, infection control becomes difficult, as the predominant mode of transmission is via droplets. And now there is some evidence that is coming up that it is probably through aerosols, that is, those smaller drops, which can last in the air for much longer times, can also cause infection. So humankind, let's face it, has not had a more than just a mildly deadly bug like coronavirus 2, which is also very transmissible and can infect when the index person is not displaying any symptoms, thus making the control extremely difficult. Drugs and vaccines take a long time for evolving, particularly for viral illnesses. In HIV disease, it took less than 10 years before the first drugs came in. A vaccine 40 years later is also not even on the horizon. Compared to this, in COVID-2, COVID-19, we already may have a vaccine in a record time of a year, as there is already the clinical phase of 1 and 2 are already being done, simply because of the intellectual and financial inputs into its development, because the global north has been affected by the disease. Brazil or other sub-Saharan African countries will have access to the vaccine after it has been manufactured, because most of the vaccine manufacture may happen in poorer countries like India. But whether all Indians who deserve it get the vaccine, whether it becomes really a public good in the world, we don't know. There's been a lot of questions about what has caused this pandemic, why now. So it may be prescient to consider, what Rudolf Virchow, the famous German doctor who turned a parliamentarian, said in 1865, that if disease is an expression of individual life under favorable conditions, then epidemics must be indicative of mass disturbances of mass life. Let us explore whether this explains this pandemic. Early on and even now, the media is agog with allegations of biological warfare. In fact, one state premier whom we know called it a virus with the name of another country prefixed to it. There were other allegations related to eating habits of another culture. There were some prophets of doom who had other theories to explain the occurrence. But we should realize that there have been several scientists who have been working on this question for years. And it seems one thing that they had already been saying for long years, that it is not whether the next pandemic would happen or not, but when was the question and what would be its impact. And we were therefore caught unawares, and because we always don't like to prepare, and thus this pandemic happened. So forces that may have worked to cause this pandemic include environmental degradation, the climate change that has hastened in the last 2 decades, the mass scale of movements of humans into new areas and of birds and animals from after deforestation and after the need for land for human beings and other animals has happened, and those of movement of one species into a new territory, and also increased inequity and injustice. As we know that 26 individuals own as much as 50% of the wealth of the human beings. 26 individuals. Man has affected the animal and microbial world in many ways, and that effect is increasing. Even though since it started about 10,000 years when man started practicing settled agriculture and domesticating animals, but there's been a larger prolonged interaction between man and animals which has increased over these last 10,000 years. In fact, the illness called influenza came into humans due to interaction between man, domestic water birds, as well as poultry. Coronavirus also similarly infects mammals, including humans and avian species. So the other changes that have happened in the Anthropocene era that we are living in is an increase in mobility. So in COVID times, as we can call it now, this has taken breathtaking mobility. So people, animals, and microbes can now reach from one place to any other place on the globe in less than 24 hours. So I would say that this search for the possibility of COVID being a biological warfare is neither likely, nor is it a useful direction to pursue. The typical signatures of genetic manipulation are just not there. And even if it is a laboratory error due to which the microbe came out of a lab, how would it spread to all the other countries without humans actually doing it due to their own neglect? So I would say the suspected origins in a wet market, wherein wild animals may also be there in some of these wet markets, is not so dissimilar from non-human flus which jumped from one species to another. Animals as food have large environmental and health consequences, and they should not surprise us. Even without it, pandemics are possible from many other human and animal interactions. We all have a right to our cultural habits, including what we and how should we eat things. And even if it is for a preservation of biological diversity and respect for all animals, all lives, these eating habits that tend to be blamed account for a minuscule proportion of global eating practices. So, and we should realize that epidemics and pandemics are not sudden random events. Microbes like viruses and bacteria jump species regularly, and genetic changes are also happening regularly. So some mutate to a favorable strain and spread as a pandemic in an immunologically naive and highly mobile population. till date, there is no antiviral drug that works in curing one from COVID, very clearly. Despite the efforts to repurpose older drugs, using existing drugs for a new disease, and some efforts to develop a new one, only one drug, which is a steroid called dexamethasone, has been shown to improve outcomes in those who are sick enough to require oxygen, not in all people. And besides this, there is another drug called remdesivir, has been shown to reduce ICU stay in some people who are moderately sick. But as of now, the drug remains highly expensive and is impossible to be used, on an equitable basis for all the people who need it. All other drugs, and there's a long list of this, biologicals like hydroxychloroquine, lopinavir, ritonavir, tocilizumab, favipiravir, interferon, ivermectin, and convalescent plasma have not been shown to be effective in preventing the transmission or curing the disease. At the same time, immune boosting or even COVID, COVID elimination strategies from pure alchemy, anti-science, and non-science have happened, like consumption of methanol to homeopathy to one Indian system of medicine called Ayurveda, doing the rounds. None of these have been proven to be of any survival value, and we are finding proof that these medicines are not useful also. So another drug that works well is oxygen. 15% of people with COVID may turn sick and they may require oxygen. And if they are short of oxygen, then when they require it because of lung involvement, the people might worsen. So I think oxygen would be one drug that we should ensure that it should be there. 3% of all people and 20% of those who require oxygen might require ventilation, respiration, and ventilators has hogged the limelight in terms of the technology that should be inserted. And we know that it doesn't. The outcomes in those people who require ventilation may have 10 to 20% of those surviving. So for value for money would be to spend in getting oxygen for people. The other two things that have seemed to have worked is high flow oxygen, which also is expensive, but also nursing people lying on their belly rather than lying supine or lying on their backs has been shown to work. So lying on belly is supposed to improve oxygen delivery to the lungs, and therefore it may be better in a way. So the other thing that might work is to prevent people who are over 60 years old and those who have various illnesses like diabetes, heart disease, and all. It is important to check when they get COVID for signs of breathlessness or falling levels in oxygen to be able to act in time. In preventive strategies, I would say that we had a sudden increase in the lexicon of this year. The words like quarantine, isolation, social distancing, lockdown, flattening the curve, herd immunity, hotspots, containment zones, work from home, masks, and hand hygiene have become almost common words like hi and hello. So quarantine, as we know, is isolating people when they come in contact with a larger community from outside on the suspicion that they're carrying disease agents on their bodies, and they have to be kept aside for a duration equal to the incubation period of the disease. So that is 14 days for coronavirus, COVID disease. And isolation is in differences if you keep an infected person away from healthy or vulnerable people till one turns non-infectious. So that is always a difficult thing. But we know that hospitals would be keeping people all the people who are infected in hospitals runs the risk of transmitting other to the hospital staff and also to the people who are coming with other diseases to the hospitals. About flattening the curve, if I may add a word here to explain, it is not about reducing the number of cases. This word has become very popular as a means. All countries have been using this, that we should have lesser number of cases coming every day. What we really are talking about is the number of sick cases requiring hospitalization. Those should be sort of flattened out over a longer period of time, so that the hospital capacity does not fall short. So capacity can also be increased by increasing beds and other things, but that is also very expensive. But the unacknowledged trade-off in flattening the curve is a longer epidemic. So it's not then over 1 month, then it may be over 4 months or 6 months. but it is important to reduce the overall mortality, that hospitals are not overloaded, and thus this is the role there. So suffice it to say that if the population immunity was to come with 60% vaccination coverage, with proper and near complete use of other social distancing and physical distancing measures and other non-pharmaceutical preventive intervention, the number of people who should be covered with vaccine may even come down to 20 to 30% also.
I was a proxy chair till now, so I'm going to hand it over to Thelma.
Thank you, Pravir, and my apologies to everybody for the slight blip. Somehow I'm not that tech savvy, so by some means I think the connection of the webcam somehow got missed out. But I've heard Yogesh's very comprehensive conversation, because even while I was not on it, I could hear him, and he's given a really good framework for us to take this conversation further. COVID-19 has provided like a worldwide tutorial on a variety of issues from virology, immunology to public health. Now there are lots of notions floating around, and news anchors seem to be really having a heyday over the past 7 months, giving all sorts of data minus denominators and coming to various conclusions. So this series was actually proposed because of the need to have a deeper scientific understanding of the issue and linking science and society together to see how the future can go forward. Now, before we go to the next section of the discussion, I would also request the tech team to please play this short little video that they have prepared, which will help to set the scene for the next phase of the discussion. Thank you.
Like all viruses, SARS-CoV-2 virus particles are really small. Millions can fit on a pinhead. Here is a cartoon of how the virus particle is organized. There is a covering of lipids and proteins around a core of the viral code in RNA packaged in more protein. The virus particle sticks to a lung cell via its spike proteins. The spike proteins are trimmed by enzymes on the cell surface. These trimmed ends then stick very efficiently to ACE2 proteins on the cell surface, anchoring the virus particle to the cell. The outer coverings of the virus particle and the lung cell are then pulled together and joined together. Once the coverings of the virus and the cell are sufficiently close, a channel opens and the virus RNA gets into the lung cell proper. Once the viral RNA is inside the lung cell, it takes over the cell's processes and starts making copies of viral RNA and proteins. The new copies of virus RNA and virus proteins are then assembled as hundreds of new virus particles, which can come out of the infected cell ready to infect many more new cells. Some antiviral immune responses come into operation simply by sensing virus rather than sensing a particular virus. Once triggered, these responses make interferon proteins, which make it very hard for the virus to make viral RNA and protein copies. Other immune responses sense the shapes of the proteins of a particular virus. They then expand a matching response tailored to that virus. One such matching response is to make antibodies, which stick to the spike proteins on virus particles and stop the virus particles from sticking to cells at all. Another tailor-made antiviral immune response is to make T cells, which recognize target cells infected by that particular virus. Once these T cells recognize an infected target cell, they kill it, preventing it from making more virus particles.
Satyajit, maybe as we're moving into the next section, would you be able to tell us about, the latest research in understanding the immune response to the virus at individual and population level in as simple terms as possible?
Okay, so let me take off from where Yogesh made a mention of this. And that is, he said that the virus will spread, this virus is shown to spread rapidly in immunologically naive individuals. So I'm going to try and lay out a little background, unpackaging the phrase immunologically naive individuals. Naive is a word that means very different things in very different contexts. Since everybody's seen the little cartoon video that the tech team has put together and just played, let me recapitulate that. The virus particle And viruses being incredibly small, there are millions of virus particles on the point of a pin. A virus particle, unlike a bacterium, is not actually live in the sense that there is no ongoing active biochemical process in a viral particle, whereas the bacterium has its life processes going on all the time. So in a sense, the viral particle is, if not quite not live, dormant. So what ends up happening is that the virus particle has to stick to a cell of the body in order to begin its life cycle. And this sticking is through specific parts of the surface of the virus particle. When that happens, the virus particle can introduce its code, its DNA or RNA, in the case of SARS-CoV-2, its RNA, into the cell, into a cell of the respiratory system, of the breathing tubes, the airways, the lungs. And these cells then begin to manufacture viral material, viral RNA, viral proteins, and begin to package more viral particles. And eventually, the cells get sufficiently damaged that they release viral particles, and the viral life cycle continues. Now, in this process, there is a basic distinction between bacterial infections and viral infections that it's useful to remember. And I'm going to connect this again to something that Yogesh said about antiviral drugs. Bacteria grow, viruses grow. But bacteria grow, one bacterium divides into two, each of the two divides into two each, so 1 to 2, 2 to 4, 4 to 8, 8 to 16. Viruses, as I just described, will grow from one particle to hundreds, and from those hundreds to tens of thousands. So the trajectory of growth of virus numbers can be much steeper than the trajectory of growth of bacteria. And this basic difference in their, shall we say, lifestyles is central to the point that Yogesh made about antiviral drugs. Even very effective antiviral drugs in some specific viruses, such as the herpes viruses, in a clinical setting, don't work as spectacularly well to relieve severe illness as antibiotics work for bacterial infections. While the virus is growing, what is the body doing? So the first thing that the body does is it's not going to do one thing. A whole number of different and sometimes interdependent, but sometimes quite independent body processes are triggered, are activated by viral infection. Some of them are useful, some of them are actually not useful, as we will come to eventually. The first one that will come into operation is as a result of sensing the presence of a virus, not this particular virus, but any virus. And it's that process that initiates the earliest body response to stop viral increase in viral numbers. And that is making interferons in the body. These interferons make cells of the body resistant to viral takeovers, and therefore the growth of the virus is repressed. People will keep in mind that because interferons have this basic antiviral function, these category of interferons, the so-called type 1 interferons or interferon alpha beta, has been one of the small handful of therapeutic interventions of medications that have been tried and tested and found to be modestly useful. Yogesh made the point, and I reiterate, no therapeutic intervention, no medication has been found to be spectacularly useful, but certainly interferons like dexamethasone have been found to be modestly useful. This, however, the interferon response is simply a response to any virus. On the other hand, there is a whole set of bodily responses which specifically recognize shapes of this particular virus and will respond to it. So that the response will recognize only this virus and no other virus, or more correctly, similar viruses and not completely different viruses. One of those responses will make antibodies. So how do antibodies work to prevent infection? As we said, viral particles come and stick to cells. And this happens through a particular virus-cell interaction. If an antibody that the body makes, which is a protein molecule, covers that part of the virus particle which is going to stick to the cell, then the virus particle cannot stick to the cell and it cannot start its life cycle. And that is the simplest model by which the immune response prevents viral infection. This is one of the reasons, it's only one of the reasons, but it's one of the reasons why we are all interested in the antibody responses of infected individuals. Yogesh made reference to convalescent plasma being tried so far indeterminately as therapy. And the background to that, technically, is that people who have infection will have generated antibodies, and these antibodies will lead to such stoppage of viral infection. In addition to this, there are other cells that can kill virus-infected cells. The trouble with that is we're not quite sure how to measure them in large scale, and we are not quite sure what precise role they play in viral infection. So there's a lot that we don't know about the immunology of COVID-19.
We are going to have a second, on August 8th, we'll have a second discussion series. We'll announce the panel for that. But the idea is also to frame the larger question, the interaction between animal kingdom, human beings, and infectious diseases. How do you really see it? And also look at then what should be the policies. How do we look at it in that terms? So yes, I do want this series to look at science as well, because if we don't, then what we tend to see is not non-science simply, but also nonsense. And therefore, it's important that we also put or take the opportunity of such pandemics, bad as they are, disasters as they are for a lot of people, but also to foreground how we should look at nature, how we should look at ourselves, how we should look at all these issues scientifically. With that, I'm going to thank again everybody, and that's all we have. And we hope that you will also join in on August 8th at the same time for our next panel discussion.